AI in healthcare. We've all heard the promises, right? Billions of dollars have been poured in, with countless headlines about a revolution in patient care. And yet, despite all that hype and some genuinely brilliant tech, the real-world impact has been, well, surprisingly small. So many of these incredible tools are just being ignored or even abandoned in the very clinics they were built to help. So what is going on? In this explainer, we're going to unpack this paradox of why so much good tech fails in the real world.
This is the big question, isn't it? It's what leaders, developers, and clinicians are all trying to figure out. The thing is, it's not about a lack of smart technology. The problem goes a whole lot deeper. And thankfully, a recent really comprehensive review of studies is finally giving us some answers.
You see this massive gap. On one side, you have the hype, this idea of AI as the perfect diagnostic genius. But then you have the reality on the ground in hospitals, which is low adoption and tools that just don't stick. This divide between the promise and what's actually happening isn't just frustrating. It's a huge barrier to making patient care better.
So here's the core takeaway. The reason these tools are failing isn't because the algorithms are inaccurate. No, it's because they don't fit into the messy, complex, and deeply human world of clinical work. It really is a fundamental problem of alignment.
To really get our heads around this, we're going to use a simple but really powerful framework. It's called Task Technology Fit, or TTF for short. All it means is, how well does a tool actually help someone do their job? I know, it sounds super obvious, but you'd be surprised how often this key piece of the puzzle gets missed by AI developers.
Okay, so the TTF model gives us three crucial pillars to look at: the technology itself, the specific task a clinician is trying to do, and of course, the individual clinician using the tool. Let's break down each one because this is how we'll build a blueprint for AI that actually works.
All right, let's start with the technology. What features make an AI tool genuinely useful in a high-stakes place like a hospital? Well, the answer might not be what you think.
This quote, it's from an ER doctor talking about a sepsis risk score, and it says everything. It just perfectly highlights the problem with abstract numbers. Even a really precise percentage is often kind of useless if there's no clear context or a suggested next step.
And this gets to the absolute heart of it: actionability. Clinicians don't just need another number to keep track of. They need to know what to do. An AI that just spits out 73% risk is way less helpful than one that says, hey, you might want to consider this specific intervention, and here are the modifiable factors why.
You know, this idea of modifiable factors is what makes explainable AI actually useful. A tool that just points out a patient's age, well, yeah, thanks, the doctor knows that. But a tool that highlights something the clinician can actually change, like a medication dose or a blood pressure target, that becomes a true partner in care.
This brings us right to our second pillar, the task. Because look, it's not enough for a tool to just be actionable. It has to solve a real, tangible problem inside the chaotic daily workflow of a clinician. And the research is really clear about where AI can make the biggest difference. It's not about replacing doctors, it's about augmenting them. It's helping to prioritize the sickest patients in a packed emergency room, or spotting subtle trends so you can intervene earlier, or maybe just serving as an objective check against the brain drain of alert fatigue and our own unconscious biases. These are the jobs that clinicians actually want help with. But even in those areas, there's a huge challenge, and this cardiologist absolutely nails it. Every single patient is unique. They have a complex history, a different physiology, a whole social context that standardized algorithms just have a really hard time understanding. And this gets us to a fundamental limitation, at least for now. AI can't replicate what doctors call clinical gestalt. It's that intuition, that gut feeling, that holistic view that a seasoned clinician builds over thousands and thousands of hours of experience. It's the ability to see the whole patient, not just a collection of data points. And that leads us perfectly to our final and maybe the most important pillar of all, the individual clinician, the human being who has to ultimately decide whether or not to trust the machine. See, a clinician's decision to use an AI tool isn't some purely rational calculation. It's this complex mix of their own hard-won expertise, how well they understand or maybe misunderstand how AI works, how much they trust their own intuition, and all the little cognitive biases that affect every decision we humans make. This sets up the most critical question in this whole human-AI collaboration. What happens when an experienced clinician's gut feeling says one thing and the algorithm says something completely different? Does that mean the tool has failed?
And here is the most fascinating twist from all the research. When a clinician disagrees with the AI, the tool hasn't failed. In fact, that exact moment of friction is often where it provides its greatest value.
This quote from a senior physician is just so powerful. The AI's conflicting opinion acts like a cognitive speed bump. It forces the expert to just pause for a second, to reevaluate their own judgment, and to ask that incredibly important question. Wait a minute, did I miss something? This creates what you could call a critical reflection loop. The AI challenges the clinician, who then takes a second look and maybe orders one more test or grabs a colleague for a quick consult. So even if the AI was technically wrong, its disagreement can prevent tunnel vision and lead to a better, more thoughtful decision. It can stop a potential oversight in its tracks.
So if we put all three of these pillars together, what does the blueprint look like? How do we design AI that clinicians will actually use, that will actually improve patient care? First things first, we have to reframe the goal entirely. The AI isn't some all-knowing oracle that's supposed to give final answers. Think of it more like a highly specialized consultant. It brings a unique, data-driven perspective to the conversation, but the final call remains firmly in the hands of the human expert. This simple reframing leads to a really clear set of design principles for building AI that truly works. You want to complement clinical expertise, not compete with it. You have to design for actionability, explain the factors that can actually be changed. And finally, you have to measure success differently, not by how often doctors blindly follow the AI, but by whether the tool helps them make better, more reflective decisions. Because ultimately, the goal isn't just to build a smarter machine. It's to build a smarter, more effective human-machine team. The real revolution in healthcare isn't going to come from an algorithm that replaces doctors, but from one that makes great doctors even better. So the question for all of us is, how are we going to build that team?